So I'm Kellet Atkinson. I'm the director of product at DZone. And for those of you who don't know about DZone, we are an online community for developers and technologists, people who are professionally involved with building software. And our community is made up of millions of people in the industry who, and all of our content comes from our community members. So if you come to DZone, you'll find content from people practicing in all corners of the earth and all corners of technology space, sharing their experiences and sharing technologies, our tutorials and best practices and opinions. And we do research in the space, and a lot of people know us for our ref cards, which are our kind of cheat sheets on a whole bunch of different technologies. And so today, we're one of our big focuses is connecting people in the industry to talk, to kind of cut through. I think a lot of what's out there on technology is really marketing oriented, trying to get people to adopt technologies, and we try to focus more on the real world applications and people actually using the technologies and their experience. And so we've started to do these panels as a way to connect people kind of on the front lines of these technologies to talk about their experiences, what's working, what's not working, what they're excited about. And so today, that's kind of what we're hoping to do. And so we have a really interesting panel. I will go around, and I would like for each of you just to start off, just to introduce yourself, where you work, what you do, and then maybe a brief a brief explanation of your interest or experience with Kubernetes in particular. So we will kick off with Boris.
Yeah, hello guys, my name is Boris. I'm software cloud architect expert. So I'm passionate about building solution, distributed systems that solve complex problems. So also all this solution based, not all, but a lot of them are based on Kubernetes plus Docker, Azure Service Factory, which focus on cloud providers like Azure, Google Cloud, AWS, and any other cloud. Also, my areas of interest includes like enterprise cloud solution, multi-tenant distribution systems, and IoT stuff, edge computing, and high-load web API, and so on. So, in particular, Kubernetes experience, I think I have around 3+ years. So I started my Kubernetes journey, so to say, from bare metal product and project when it's started from the deploying manual or virtual machine and deploying Kubernetes there. So, and now, fortunately, I'm using cloud providers for Kubernetes like Azure, K8s, and Google Cloud Kubernetes services. And of course, introducing it to my customers and in my products and projects.
Awesome, thanks, Boris. I'm just gonna go in the order that I see you guys on my screen. So next, I would, Samir, why don't you introduce yourself?
Sure. Hello, everyone. I'm Samir Behra. I am from Birmingham, Alabama, working as a senior architect in EBSCO. Again, I have been working in the cloud space for over five to 6 years now, primarily in Kubernetes area for 3 years. Been involved in a lot of migration, like from on-prem to the cloud, using all the cloud native stuff, technologies. So yeah, I'm really looking forward to this session. I've seen a lot of organization, a lot of my colleagues. I would say I also run the user group, tech user group in Birmingham. So I see a lot of folks interested in adopting to the cloud native technologies. But again, there are a lot of pros and cons, and like a lot of challenges as well. So again, I'm looking forward to this discussion. Yeah. Thank you.
Awesome. Thanks, Samir. Okay, so next we have Matt. Why don't you introduce yourself?
Hey, thanks, Kellet. Hey, everyone. I'm Matt Johnson. I'm a developer advocate at Bridgecrew. So my day-to-day job involves looking at, how we kind of integrate security in a way that doesn't annoy developers, basically. So, how do we kind of get that sec into DevSecOps? How do we keep that within the existing pipelines, the existing workflows, the existing day-to-day kind of tool sets that developers are using, so that it doesn't become like a separate manual or annoying thing to have to secure your infrastructure. And we do that by looking at like infrastructure as code manifests and trying to find as many issues up front as we can. So yeah, like always been a bit of a security geek, but my kind of container journey started like right back with Solaris zones and LXC. I did a brief stint at some microsystems during the wonderful Open Solaris era. And through that kind of into Mesos Marathon, into, orchestrators, Docker, and then kind of into Kubernetes. And in my previous role, I saw a lot of, as has kind of already been mentioned by a couple of people, kind of movement from Kubernetes, from kind of, on-prem or other cloud environments into Kubernetes, and the start of containerizing and then splitting into microservices from lift and shift. So yeah, a fairly dotted history with Kubernetes, but personally really interested in Kubernetes at the edge, especially with like, non pre-made devices. So, bringing that kind of cloud API, cloud provider experience to kind of bare metal, white labeled hardware. Working on a couple of projects in my spare time around kind of making that process easier than it is at the moment.
Awesome. That sounds super interesting, Matt. And I hope we'll get to hear a little more about that today.
Cool.
Next up, I've got Patrick.
Yeah, so I'm Pat Brennan. I work for Gremlin. We're the leaders in chaos engineering. Chaos engineering is all about finding weaknesses in the environment, identifying those weaknesses, remediating those weaknesses before you have an outage, so that you can, increase your revenue, increase your customer satisfaction. I too worked at Sun Microsystems. So yes, I'm familiar with zones as well as there are zones. And I worked with LXC and so forth. With Kubernetes, what we do with Kubernetes is we really kind of look and say, okay, Kubernetes can be, abstract a lot of layers. It can be complex and things like that. So we kind of really go and help run various failure scenarios as it would relate to Kubernetes, whether it's pod, scaling, performance, those things. So I'm a principal architect at Gremlin, and I kind of go and help customers figure out how they can go and optimize and avoid failures in their Kubernetes environments for increased performance. I've worked with OpenShift 3, OpenShift 4, kind of saw the involvement of OpenShift over the years, as well as, the various cloud providers, EKS, AKS, GKE.
Awesome. Thanks, Patrick. Okay, so the last person I've got on my screen is Ritesh.
Hey, thanks, Kellet. Hey, folks. I'm Ritesh Patel, co-founder and lead products and marketing at Nirmata. So at Nirmata, we provide a management platform for multi-cluster, multi-cloud Kubernetes. And we're also a founder of the open source project Kyverno, which is a Kubernetes native policy engine. And we've been in the Kubernetes ecosystem since its inception. And even before Kubernetes, we were providing our solution around Docker. So we're definitely interested in all of the issues and helping enterprises kind of in their journey to cloud native, right? With cloud native technologies like Kubernetes and other aspects and around Kubernetes. So we essentially work with mid to large enterprises and help them simplify Kubernetes and adopt Kubernetes in their environments.
Awesome. Thanks, Ritesh. Okay, so we have now met the panel. To get started today, I thought we might we might start with kind of a high level topic, which would be, it sounds like a lot of you have experience working with a bunch of different companies that are going through this journey. And my question to kick things off is, what is it that brings people to want to move into containers and Kubernetes, and what are the things that they should be thinking about when they're exploring that option?
Well, I think so. The first maybe point, unfortunately, it's hype around this Kubernetes and Docker. So a lot of customers comes and say, "Aha, I have a lot of virtual machines, but we think that Kubernetes will solve all our issues." Exactly. And then this is when this story comes to the when you start analyzing what they have just 10 or 15 VMs, which can be just simply wrap around some good infrastructure, and they don't need such complex system like Kubernetes. So this is the first point from my experience. And another one, when Kubernetes indeed helps enterprise systems to manage all their workloads. So yeah, it kind of, and people also have like 200 and 2000 virtual machine, somehow operated by some load balancer and gateways. And yeah, indeed, Kubernetes help them a lot, especially with auto-scaling mechanism in place. So yeah, but unfortunately, first point is a hype.
I would echo that completely. I think it is all the rage. People say, okay, I hear containers, everyone's doing containers, I have to do containers. Going and just taking your applications and moving them into a container, not necessarily the best thing to do. You know, the way that you might go from on-prem to a cloud, and there are management differences that you have to deal with when going from one to the other. Kubernetes can be complex. There are multiple layers. There are security issues. There are performance issues. There are best practices around defining CPU limits and requests, same for memory limits and requests, and how you go and define that. So it is complex, and I think some people really go and forget that as they start going to Kubernetes, thinking, well, Kubernetes provides high availability, but it's complex because you have to understand the layers. You have to understand that you talk to a service, you don't talk to a pod, and things like that. So you really have to understand the multiple layers of Kubernetes. And I think that sometimes gets lost when people just say, oh, we'll move to containers and go to Kubernetes.
So just adding to that, and what we see when we work with enterprises is really there are some motivators or drivers, right? If enterprises essentially, if they have applications which they really think would benefit from, converting or migrating to a cloud native microservices style architecture, that's when kind of the discussion around containers and Kubernetes starts, right? If you're doing microservices, typically, now leveraging VMs would kind of, not be the most appropriate choice, but you want to move to containers. Now, if that's the case, and obviously there are a lot of challenges and issues to deal with and understand, but if you're moving to containers, what's next? How do you orchestrate those containers? And that's when discussion comes around to Kubernetes. Now, the question comes down to, does the enterprise have the capability or the capacity to support and enable a platform around Kubernetes in their organization? And a lot of large enterprises do, maybe financial services, maybe large, technology companies, SaaS companies, they do. Or do they leverage a cloud-based solution which is built on top of Kubernetes, which provides some level of abstraction and simplifies the ongoing operations? So that's kind of the way this discussion progresses, and we see enterprises take one path or the other depending on their capabilities. But along that journey, solve a lot of these problems. Ultimately, their goal is to get that DevOps agility, right? It's all about being able to respond to customers faster, being able to deliver features and capabilities sooner, being able to deliver reliable software. And those are the business drivers. But how do you get there may vary depending on their capabilities, teams, and their needs.
And I think just to add to that, the value of shifting from, having to deal with whole operating system images and VMs and load balancers and system D into, a much simpler, GitHub Actions, for example, plus a couple of Docker builds, that process of kind of moving into smaller components rather than kind of big OSs is hugely valuable for that agility. The question becomes when Kubernetes was like 6 API resources and you just had a pod and a deployment and a service, it was actually very simple to see how you could say and take that simple container and put it in this simple orchestrator. I think the question is now whether that simple orchestrator still holds true, or whether for those users some value could be gotten out of just kind of, for those more simple use cases, still get the value out of a very simple Dockerization container, but then something like ECS or just a simpler runtime where you don't need the kind of full set features of something like Kubernetes.
Yeah, and again, I pretty much agree with everyone what they mentioned. I just want to also focus on Kubernetes being an open source orchestration tool, right? So that's one of the big edge which Kubernetes has, wherein no matter where you are running your applications, you can easily kind of use Kubernetes. And again, Kubernetes has helped increase kind of the adoption of like containers, microservices as a whole. It's very popular in the developer community, right? And once you have like hundreds of containers and services running in production, you will need a solid container orchestration solution, and also kind of the support system which Kubernetes has, like in the open source community itself, like from a monitoring aspect, there are a lot of supporting tools which you can start using without any cost. So that's where I think Kubernetes has an edge over a lot of the other orchestration tooling which is available.
Yeah, I think the one other thing to keep in mind is, as you're going and using Kubernetes with your applications, Kubernetes, yes, it assigns where the pod runs on the system. You could do horizontal pod autoscaling. But the other thing to keep in mind is that your microservices application, what you put into containers, you still have to take into account things that, you can't control, like latency and things like that, because microservices, whether they're running in a Kubernetes or not, can be susceptible to latency. So, if you're running a microservice in Kubernetes and you have latency between the pod and what it's talking to, that microservice can still break, right? And Kubernetes is not going to solve that problem. And it's important to keep in mind that Kubernetes is not the end all or be all, and that just moving to Kubernetes doesn't solve things like network latency or packet loss or network outages. So as you're kind of developing your applications and moving them to Kubernetes, you want to kind of go and say, okay, I'm still not solving that problem. I want to go and test for that. I want to account for that. The other thing about Kubernetes is that, when you're going from a VM, we typically measure things in CPU%, right? It's consuming, 20%, 40%. In Kubernetes, you have to do the math to go and say, okay, we're not doing it in percent, we're doing it in milli-CPU. And milli-CPU can be a complex math when converting from CPU percentage to milli-CPU. And so there are some complex things that when going from VMs and measuring things at the CPU level to how Kubernetes does it, which is milli-CPU. And that's something else to keep in mind as you're defining your CPU requests and limits.
So I think that leads into an interesting kind of segue, which would be, what are the things that make using Kubernetes both advantageous, but maybe more complex for somebody who's coming from like maybe a more simplified VM architecture, or like even a legacy monolith application. They're moving into Kubernetes. What are the things they need to be considering, whether it's how they're converting the CPU usage, or it's how the containers are communicating? What are the big things that people need to be cognizant of as they're migrating into a Kubernetes environment?
I think first of all, they should know the requirements for the future. What should they do? And the second one, for Kubernetes, they should first learn all aspects of the Kubernetes, because when something will fail, they should know how to quickly act to fix this issue or solve this problem. And I would say that the learning curve is quite huge with Kubernetes. So, and yeah, and it's a lot of tools around them, and you should also focus to see how to build this your architecture, how to properly assign the limits and requests for CPU and memory. It's also actually a good topic to follow here. So I agree with Patrick here. Yeah, it's a lot of things. Maybe in many cases, many customers can be even more receive more a benefit from using just a simple serverless option.
Yeah, so I think that's heavily dependent on the application, right? And I think it's very it's not really kind of, you know, straightforward to convert like a monolith application into serverless type, you know, just application, right? It takes there's a journey there. But with Kubernetes, I think the like we discussed earlier, the benefits that the enterprises or the developers or the users get is obviously, we talked about the agility. Portability is a huge benefit. You know, especially now what's happening is Kubernetes APIs and the resources are standardized. So independent of which cloud you are on, independent of whether it's on-prem or not, you get that portability. But some of the pitfalls include ensuring that your application is not tied to infrastructure. So with Kubernetes and with the scheduling of Kubernetes, how Kubernetes schedules pods, you cannot tie your application to any VM or node or any of that, right? And you have to make sure that all of the resources the application needs, whether it's storage or you know, it needs to access file system, and all of those resources are available across independent of where that pod gets deployed. So that's one aspect. Resource limits, you know, is another big aspect of it. Some of that could be automated. There are tools that let you do that, but that's definitely something to consider. Applications need to be able to handle failures, right? And the whole paradigm in Kubernetes is, you know, if a pod goes down, Kubernetes will restart it, and and the application needs to handle those failures, you know, gracefully. So there is a bunch of work that needs to go into the applications themselves as they are kind of moved from VMs to containers and then onto Kubernetes. And that's kind of a journey that we see enterprises taking. And it's a step by step. It's not something that they're going to achieve on day one. In our case, we work with large companies that take 2 to 3 years to migrate like a large monolith application into a few hundred microservices to achieve the agility, the benefits of, you know, cloud native. And you know, at the end of the day, they're providing a much better solution than they did, you know, when they had a monolith.
And I think that some of the other things to consider is, you know, again, to the point that Boris made, understanding the structure, understanding that containers sit in pods, you can have multiple pods, service talks to pods. So understanding the structure of Kubernetes. Other things to, you have to understand the pod definitions. Now the pod definitions can, be rather daunting, at first, but to go and kind of understand those pod definitions, to look and say, okay, do I just want one container per pod? Or maybe I need, 2 containers in a pod, and why, right? To go and, ask that. And then, is the sizing of your Kubernetes cluster. You want to look at the right size that you need for your Kubernetes cluster. And then there's the security aspect. How do I break up my namespaces? How many namespaces am I going to have? Am I going to have security by namespace from an operational perspective? Who has access to what namespace, right? Because there's a security, aspect that you have to think about as well. So, there are really a number of items within Kubernetes, without getting into the weeds too much, but there are different things. There's, cluster role, there's just role bindings, cluster role bindings. So to understand those things, because those have different level of permissions within Kubernetes, which have different effects. So you want to also look at it and say, I don't want to grant too wide access to the cluster for maybe a particular, pod or particular application. So as you're migrating to Kubernetes, you want to kind of think about those aspects. And that kind of goes to Boris's point of it can be a big learning curve. But these are some of the things that really need to consider.
And on the security point of that, like I would say, use the tools that are available in a couple of ways there. Like to Boris's point, with so much to consider, if you are looking to kind of drive business value and get something done with Kubernetes, you're probably better off starting with a managed Kubernetes, so you're on a solid base while you learn the basics, rather than wondering if your Kubernetes cluster is even built right. But then for deploying those Kubernetes manifests, there are free tools out there. So shameless plug for one of our open source tools called Chekhov, which will go through your Kubernetes manifests and highlight any security issues or best practices against kind of the CIS Kubernetes guidelines. So, hey, you've given this pod privileged access. Are you sure it needs it? You've not given this pod CPU and memory limits, which, as Boris says, is actually really important, because you wouldn't give a VM unlimited memory and unlimited CPU. So the same goes for any shared resource such as Kubernetes. So, use the tools that are available to kind of help you ensure you're learning best practices as you go along, because you can create a very simple pod definition that will work, which guarantees you will come unstuck with your cluster further down the line.
Yeah, just wanted to as well mention about like as we are onboarding maybe teams to start using Kubernetes, I think it's very important for them to have a basic understanding of the Kubernetes architecture as well, right? Like the master nodes, it does follows the master slave kind of design pattern. So you have the master node, you have a number of worker nodes which you will need to set up where your applications will run. So those are the complex areas. I'm not sure if we have the infrastructure team who kind of does the setup of the Kubernetes clusters, because you need to make sure that those components are in a good state. So that's where I think, do you need to manage the master nodes, or you go ahead with a managed kind of provider who will actually manage the master node and you take control of the worker nodes. And as my colleagues were mentioning about the monitoring challenges as well, troubleshooting aspect is critical as well. Like you need to have access to kind of the container logs if something goes wrong. An easy way to look at the logs. We mentioned about the resource request and limits. That's very critical when you are running a lot of services inside your clusters, making sure that those limits, the CPU limits, the memory limits, which you're asking for your containers is being used, and you're not over allocating any of your containers or pods. Configuring, say, health checks, right? You have these readiness probe, liveliness probe, all those sort of health checks, troubleshooting techniques as well. You should kind of be very comfortable. I think there is a learning curve, but you will need to get used to it to have a kind of troubleshoot any issues with your services once they are running in Kubernetes.
Yeah, and one of the other things to also keep in mind is that, whether you're running like OpenShift, you have to be mindful of the SELinux policies. You may need to go and adjust SELinux policies for your environment to allow the container to run, depending upon what it does. K8s by default now uses AppArmor, right? So you may have to adjust the AppArmor definitions to allow your containers to run. So what we're seeing is various different distributions of Kubernetes having more and more security. So as you're going and doing it, these things can easily trip you up and make it appear like your thing's not working when you just need to go and modify those security policies. So just be aware that there are things like AppArmor that AK is using, SELinux policies that you may have to go and modify. So for example, if your container needs to mount the host file system, say var run or something like that, you're going to have to adjust SELinux policies to allow that. So those are things to keep in mind, and that's why it's really important to understand what your container needs to do and how that relates to the security context within Kubernetes.
So I just wanted to bring up a kind of a topic here, right? And I think we talk about a lot of things and we talk about Kubernetes broadly, but I think we need to take into account the personas of the users, right? And when you talk about SELinux and you talk about security, who's the one who should be responsible for that? And what we see is that the cluster operator or the platform engineering team is really needs to supports the the cluster lifecycle, right? And then the developers, what are they responsible for? Developers are really care about most of the time making sure that that application is running, and they care about pods, deployment, some of the application resources which are deployed to a Kubernetes namespace. So there is a separation of concern that Kubernetes naturally kind of provides through all of these constructs, and it's very important to keep that in mind when you're talking about Kubernetes, because while it may seem daunting that a developer needs to know everything, that's not true. I mean, what we see is when the usage of Kubernetes is concerned, there are 3 or 4 different scenarios, right? Customers, or in some cases, customers want to provide cluster as a service where you can spin up clusters on demand. Other cases, they want to provide namespace as a service. So if you saw the KubeCon talk by Apple, that's one of the things they do, and providing making sure that the namespace is provisioned in a secure multi-tenant manner. And then the third one is container as a service. If you think about some of the cloud services like ECS and others, maybe underneath the covers they're using Kubernetes, but for the user, they just need to care about their image and ports and some basic things before they deploy the cluster or before they deploy their application. So I think that abstraction is very, very important. And again, there is no one size fits all in an enterprise. You may have superstar developers who want access to the full cluster, whereas you may have other developers who just want to deploy their image, and it's a Salesforce app, integration app, they want to deploy their image and be done with it. So I think I would like to hear from the panel how they view this separation of concerns and how that can simplify the adoption of Kubernetes in an enterprise.
I find myself using that word personas in pretty much every conversation I've had over the past few months with Kubernetes, especially where security is concerned, because just because, as you say, the cluster operator or the ops team responsible for managing that cluster and installing logging and monitoring, just because they need to run pods that might require extra permissions or raw network access, such as logging and monitoring daemons, you know, doesn't mean it's okay to just carte blanche accept that those policies on, you know, restricting access to those kind of privileges should be ignored. You know, that's a very different persona than what we get with a regular app developer that wants to deploy, you know, a few microservices that just need access to HTTP or, you know, access to the service mesh. And I think like it almost becomes a ecosystem issue for packaging. So something like Helm, you know, should Helm charts be tagged with whether they are targeting an operator persona or an end user persona? And should we treat them differently in terms of security based on that? Because, you know, there really is that demarcation of two very different personas running Kubernetes and the kind of privileges they need within the cluster.
Yeah, I echo all those points. I think, you know, really understanding who does what, I see it, you know, with my customers. You know, there's the group that kind of manages it. There's the application people, and they're very sensitive to who has access to what and whose role is what. So it is really, really important. I mean, this is a critical topic, and you know, I think that, you know, it really is, people have to kind of work together, understand their role. This kind of goes to, you know, maybe the overused phrase of over communicating, but it does go to that. And, you know, having different personas that are responsible for different things, the more things have become complex, you know, the more that people really need to collaborate and work together and understand what those points are so that they can make their Kubernetes environment as resilient as possible and secure.
Yeah, I think so too. Maybe even I would recommend, maybe not for all, but for some teams and some projects, it would be better than some people can accomplish the exam. So Linux Academy exams for Kubernetes, like for developers and for administrators, it would definitely help to avoid such issues in the future.
I'll add an aspect here, like from my experience, I have seen kind of a resistance generally whenever we try to push something, a new technology in a larger organization or an enterprise, right, where you have, say, hundreds of development teams who are kind of used to doing things in a different way. And there, when we ask everyone that, hey, this is kind of our new DevOps pipeline and we will be using Kubernetes for our deployment, it can create kind of a chaos environment. So like, how do we manage things there? So kind of my thoughts are like the cluster management, the Kubernetes, again, all the complexity with the administration aspect needs to be, it will be nice if it is handled by an infrastructure or a platform team. And the development teams kind of, you try to abstract away most of those complications dealing with the deployment aspect. Like you create a pipeline and give it to the dev teams, and it shouldn't matter to them where their service is getting deployed, either it is to ECS, EKS, or any other kind of platform. So all they need to do is configure their services. You have some type of abstraction built into each of the services, and you just specify, okay, this is how I need my service to be deployed into whichever platform you want to, and the pipeline takes care of most of that complication. So maybe some level of abstraction is required as you try to adopt Kubernetes in a larger enterprise, so that you don't get that huge resistance to change when you start this migration process to cloud native technologies and Kubernetes. Yeah.
Yeah, and I just want to mention one solution that we kind of help address this, and this is a plug for one of the open source projects I mentioned earlier in the intro. So we have we open source a policy engine, which is part of CNCF now, Kyverno, which enables the operators to kind of provide this level of abstraction to developers by enforcing security best practices, as well as generating some of the configuration automatically, where the developers don't have to worry about it, including like roles, role bindings, and things like that. It's becoming very popular. So really, the separation of concerns, EB3 is the key to successful Kubernetes in an enterprise.
Do you think that's necessary because of how steep the learning curve is, and it's hard for say a broad team of multidisciplinary people to all become hyper familiar with the technology?
I think there's various reasons for that, right? Again, in a small team, in a startup, maybe you can have, maybe multiple experts and, people know everything in and out, but that's not the reality in a large enterprise, right? And again, expecting developers to know every last detail of networking, storage, security is just not feasible. I mean,
Right.
It's just hard. And like, Samir pointed out, they want to focus on their application. They want to, make sure their application is up and running and not have to deal with all the details, right? Even in the past, when developers were using VMs, that was the case, right? You had, folks who would run the infrastructure and the folks who would use it. But self-service is very important, in our opinion. Developer self-service, where they don't have to wait to get access to the infrastructure, right? So that is the key. But abstracting some of the complexities is really required for for a successful adoption of technologies such as Kubernetes.
Yeah, I also agree with Ritesh regarding development, but that's why the companies, at least for a separate project team and product team, should have additional like DevOps team or architect team, which should care about infrastructure and Kubernetes itself. That developers can focus on their tasks, on the development process, and other like architecture and the DevOps stuff can focus by the DevOps team or architect team. This may solve a lot of issues itself, but at least that's how other enterprise customers does.
Yeah, the education issue is, the education issue can be a challenging one, right? So anything you can do to make it easier so that those developers can focus on their applications and focusing making their applications from their perspective as resilient as possible is really important, so that they don't get bogged down in to that point about role bindings, cluster role, and the different level of permissions within Kubernetes. It goes really to that point of collaboration and trying to have a real set of standards of things, right? So I think that just becomes really critical to the adoption and going and testing in your environment to make sure that your Kubernetes cluster is working properly, that the applications work properly with it, and that the reasons that you're using Kubernetes, you're really capitalizing and getting the most out of
it. Kind of goes back to that common topic on, is more and more of Kubernetes suddenly going to disappear under the waterline, and we're going to end up with kind of a reinvention of like platform as a service, where there's just a very small kind of, very opinionated parts of, this build pack and this code goes into this Docker image, which is fixed and then becomes a pod, and kind of everything else is more from an operational Kubernetes management perspective.
Yeah, I mean, it brings up, to me, it brings up an interesting question, because when we talk about managed Kubernetes, right, EKS, AKS, if you have a lot of pods and you have a lot of namespaces, one of the things that you don't really know that you also need to take into account is at what level do you stress out the API server? Because that's on the master nodes. So where are you, if you have 8,000 pods or something, right? you're not controlling the API server because that's on the master nodes that's run by the cloud provider, right? So, one conversation I had with a customer, which is really interesting, is how do you test where the API server fails over in a managed Kubernetes environment? When do I stress that out? Because I'm using horizontal pod autoscaling and I have a lot of demand for things. COVID kind of changed the way it works. So all of a sudden I have a lot more demands on my environment. I'm spinning up a lot more pods. Where does my API server fall over? So because it's managed, I don't have control over that. And it kind of brings up an interesting question, is that I really have to think about the capacity. Maybe I have one big Kubernetes environment. Maybe instead of that, I have smaller ones and I have 5 of them. Because one big Kubernetes is not the answer to it, depending upon what the demand is from your customers on your application. You have to kind of think about it and say, okay, do I maybe combine horizontal pod autoscaling with Kubernetes with just autoscaling where I add nodes? So I kind of use them in combination with one another. Those are performance issues that kind of a platform team has to think about, because the whole point is to serve one's customers.
Hey, I kind of agree there. Like, as we are adopting kind of all this the microservices architecture and all the DevOps pipelines and all, the actual problem statement doesn't go away. Like microservices, they come with a lot of complexity. Say tracing, you have service discovery, you have circuit breaking, distributed logging, maybe monitoring. So there are so much of challenges, and all we want to do as part of either using Kubernetes as your orchestration platform, or like any other tooling, like as we are adopting any cloud native technologies, we want the intention or the goal is to make like to deliver business values faster. The development teams, they need to kind of focus on the application logic. They shouldn't have to worry about all these networking, all these platform level details. And the more the amount of abstraction we can provide to them, the better it is. Again, we have Kubernetes. Again, we have service mesh. I think that's kind of getting very popular these days, wherein inside your container, basically, apart from your application, like inside that pod, apart from your application container, you also have a sidecar, which kind of manages all the interaction between the different services. And that gives you a lot of out-of-the-box functionality, like circuit breaking and all these, the tracing. So that makes the life of developers a lot more easier, where they don't actually have to code or write code for all these different aspects, like circuit breaking and tracing, all the health check. Everything is provided out of the box by these tooling. And you just focus on your application and just kind of deploy your services and release business values faster.
All right, guys, we're at 11:51, and I promised myself I would leave time for questions for people this time around. So I really I want to open up the floor for any questions from our attendees here. Get a chance to ask the panel anything you want, and you can type it in the chat, or you can unmute and ask the question directly to the panel. And if we don't get any questions, I'll ask you a question.
I can ask some question.
That would be great.
So that someone know the history of Kubernetes, so how this comes up, and what's the history itself, where it comes from, and so on and so forth. Just like some casual talk.
That's a really great question. So Kubernetes was born out of Borg at Google, right? So Google
Yeah.
developed Kubernetes, and it was unwound from Borg, right? Because everything goes back to Star Trek, But it's that's kind of their internal system, and they had to kind of unwind kind of some proprietary items aboard to roll out Kubernetes. Kubernetes, we refer to it as K8s because it's basically taking the letters and just narrowing it down from Kubernetes to K8s. And it kind of goes. Kubernetes relates to a Greek element. If you kind of Google Kubernetes, you'll get there's a Greek definition for it, right? And that's why we also have Helm, which is all about charting and the Cs and so forth.
Yeah, thank you, Patrick. So Google now internally still using Kubernetes, interesting, or a system like this, or it was just like some creating a hype that have a look, we create a system that we are using. But
yeah.
Yeah, and Kubernetes is based on internal systems at Google, but one thing to remember is it's complete rewrite in Golang, from scratch, right? It uses the principles, but it's eventually like it has a lot of kind of constructs and other things that have been contributed by the community. It's a rewrite from scratch, and I think that makes it really kind of powerful because they've the initial team, the founding team, that came from Google and Red Hat and others. They've kind of learned from previous systems like Borg. Before that, I think Omega, and even at Red Hat with the early incarnation of OpenShift, and then kind of added like all of the learnings from that into Kubernetes. So I think that's why that makes what makes Kubernetes like really interesting and appealing to a lot of folks.
So we should not deploy our own website to Kubernetes, right? Because it will be a little bit awkward.
I've got a question from the audience. Did you want to chime into that, Matt? Go ahead.
Yeah, I was just going to say as well, I think compared to kind of Borg internally, like no one, unless you kind of have worked at Google, will tell you exactly the differences. But I should imagine, running your own infrastructure and data center where you're building your own data center from the ground up, you probably don't need all the pluggability for all the different scenarios that kind of Kubernetes has to support. So I should actually imagine it's probably a much more restricted kind of minimal set of APIs than what Kubernetes has become. Just because of the kind of single track focus.
All right, so we've got a question from Steve G. And I think since we don't have any other questions, this could be our last question. And it'd be each of you maybe take a second to answer this. His question is, can you offer one of the most common yet avoidable pitfalls in moving to Kubernetes? And let's, yeah, you can speak up actually. I was gonna just call out names, but you guys, you can take turns and speak up.
Shortly from my side, it's a lack of knowledge. It's the big pitfall. And understanding whether we need it or not so. But I'm not against Kubernetes, don't get me wrong.
Yeah, I think one of the pitfalls is that people just roll into Kubernetes without thinking about the best practices and kind of the abstract layers that you need to account for. And I think people just think, well, Kubernetes provides high availability and this and that, and that's not entirely true. It is, you have to kind of look at the broader element of how Kubernetes works and just take a step back, take a deep breath and go and say, okay, how does Kubernetes work? And how do I go and take my application and fit it in and follow those best practices? Some of which we have taught today, whether that's the CPU limits and requests, so you don't get a runaway thing that consumes things. going and make sure you have the right policy, security policies, really going and taking that, because otherwise you can run into real problems and real difficulties.
And I'll add on to that, like just the monitoring aspect, the monitoring challenges which comes with Kubernetes, right? Because like once you adopt Kubernetes, you will have a lot of these moving components, and it is kind of difficult to have a complete observability on your application stack and as well on the infrastructure side on the Kubernetes cluster as to how things are. So there's where I think if you have the right tooling, like if you know which all metrics to catch from the Kubernetes perspective, and then kind of send it to some tools like Prometheus, which will kind of act as a data store for all the metrics, and then having the ability to kind of query Prometheus and pull in the metrics which you need to kind of have a good confidence of supporting your application, like the red metrics and all for your application, and then the health checks for your worker nodes, for your master nodes. So those all aspects, I think those are a few of the challenges, but there are great tools available in the open source world, which you can start leveraging to make that transition a lot more smoother.
Yeah, I think I kind of echo all of that. Like, know how you are getting alerted if your application fails, and if you don't know that, you've not got to the end of your deployment. Like, if you are getting to the point where you think, holy crap, like this is a lot of effort, like Kubernetes was meant to solve these problems, this is a lot of effort just to run one application, you are probably doing it right. Because it should feel like a lot of effort, because it's not designed to run one application well, it's designed to run thousands or tens of thousands of applications well. Yet the upfront cost in understanding the monitoring and the alerting and how you define your pods in a useful way so that Kubernetes won't fail you is actually quite a large piece of upfront investment in Kubernetes.
Yeah, and I think I second that. And the education is key, right? Educating yourselves around the various aspects. Kubernetes is fairly powerful, but then obviously, like we've pointed out earlier, there's a lot of knobs that you need to tweak to kind of get things working. And a simple example, and one thing we see very often is a lot of times when somebody deploys an application and the pod doesn't run. They need to know where to look at, right? What are the different constructs available to look at, and in a lot of cases it's very simple, like the pod image could not be pulled, and how do you figure that out, right? There's no alert built in that's going to tell you that. So you need to really know your way around the various resources and kind of be able to dig deeper when you start deploying your application. So I think what everybody's talking about, like having the knowledge and the education when you start using Kubernetes is definitely the key.
Awesome. So I think we got everybody in there, and out of respect for everyone's time, I think we will move to wrap up. I really appreciate all of you taking your time out of your day to share your knowledge with your peers and the attendees, and I hope this was a useful conversation. We will post this on our YouTube and out on DZone later for other people to watch, for you guys to share with other people. For the attendees here, Blake dropped a survey in the chat. Take it and let us know what you thought. Also for the panelists, you guys feel free to fill out the survey as well, so we can continue to run these and improve them and make them better. Again, thank you all for sharing your time. And last note I'd say is, if any of you are interested in writing for our Kubernetes trend report, which will be going out in the second half of the year, you can reach out to me directly or to our team. And I appreciate everything, and we will hopefully we'll get another one of these together soon.
Right. Thank you.
Thank you, Kellet.
Thank you.
Cheers,
Thank you very much.
Everyone.
Yes.